We're now going to talk about inverse functions. Inverse functions are functions that basically undo each other. Like inverse operations, addition and subtraction are inverse operations. Multiplication and division. Squaring, square rooting, those are inverse operations. Inverse functions are functions that the end product gets you back to where you started. The definition of that would be that f and g are inverses if f of g of x is equal to x and g of f of x is equal to x for all x in the domain of f and g. Okay, for example, maybe a concrete example will help. If we wanted to show that f of x is equal to 6x minus 2 and g of x, which is equal to x plus 2 over 6, we want to show that they are inverses. So show that f of x and g of x are inverses. To show they're inverses, you have to show two things. We have to first show that f of g of x is equal to x. So we're going to take x and plug it into g, which gives us x plus 2 over 6. And then we're going to plug that into f. So we're going to find f of x plus 2 over 6. So we're taking x plus 2 over 6, plugging it in here. So we get 6 times x plus 2 over 6 minus 2. 6's cancel. You get x plus 2 minus 2, which is equal to x. We're halfway there. We've shown that f of g of x is equal to x, so we've shown this. We now need to show this, that g of f of x is also equal to x. So g of f of x means we're going to take f of x, which is this function, and plug it into g. So we're going to be finding g of 6x minus 2. So we plug that in here for x. We get 6x minus 2 plus 2 all over 6. The 2's cancel. We get 6x over 6, which is equal to x. So, because f of g of x is equal to x, g of f of x is equal to x, we could say, therefore, remember the 3 dots is therefore, f and g are inverses. Now, because f and g are inverses, what that means graphically, f and f inverse, this little sign, the negative 1 there means inverse. That's not an exponent, so that's f inverse. They are reflections over the line y equals x. The line y equals x is a diagonal line that goes through the origin, has a slope of 1. So looking at these two functions, we know that f and g are inverses. If we were to graph 6x minus 2, when it goes down 2, that's the y-intercept. We go up 6, whoops, and over 1, so there's going to be the second point. It's going to have a fairly steep slope. There is the graph of f. Now, this is in slope-intercept form. It's easy to graph. This is not right now, but I know that they are reflections over the line y equals x, which is that diagonal line. And so it's inverse. They're going to meet at the line, and so they will look something like this. So this would be f, and this would be g, and they are inverses, so they are reflections over the line y equals x. What that also means, think of our function machine. Means if we take a number, any number, let's say 15, and we plug it into f, it's going to spit out a number and drop it into g, because the two functions are inverses, they undo each other. So 15, f is going to do something to it, drop it into g, g is just going to undo it and spit out 15. So for your input, your final output is exactly the same as where you started. Now this is a different type of question. Now that we've shown that two things are inverses, in this one we're given a function and we want to find its inverse. So those are two separate types of problems. Here's how we find its inverse. Instead of writing it in function notation, let's write this as y equals 1/2 x minus 1. And we simply change the x's and the y's. So instead of writing y equals 1/2 x, write x equals 1/2 y minus 1, and then solve it for y. So I'm going to add the 1 over. So x plus 1 equals 1/2 y. Multiply both sides by 2. So we get 2x plus 2 is equal to y. This is the inverse of the original. So then finally, to use function notation, if f of x is 1/2 x minus 1, f inverse of x is equal to 2x plus 2. Now when it comes to domain and range, the domain of f is equal to the range of its inverse. And the range of f is equal to the domain of its inverse. So the domain and the ranges switch. And if you think back here, when we did this little switch, remember x is our domain and y is our range, we switched them. Okay, we're switching domain and ranges for our function and for our inverse. If we were given g of x is equal to x squared, and we wanted to find g's inverse, using the same method, we'd have y equals x squared. So x equals y squared. We take the square root of both sides, so y would be the square root of x. But remember what we talked about graphically. The square root of x looks like this, and x squared looks like this. And remember, graphically, we said they are reflections over the line y equals x. They are reflections over the line y equals x. However, they are only reflections in this first quadrant. Therefore, these functions are not considered inverses over their entire domain. We only have an inverse function for the domain from 0 to infinity of our original, because that domain became this range, and that range became this domain. So sometimes their functions and their inverses have limited domains and ranges. A function like the top one is called a one-to-one function. The bottom one is not. A one-to-one function is a function if distinct inputs yield distinct outputs. So a one-to-one function for distinct inputs yield distinct outputs. So simply what that means, if you look at it, kind of in the idea of our function definition, for every input there's a unique output. For every output there's also a unique input, which might be easier thought of as it has to pass both the vertical line test and the horizontal line test. So this function is linear, and a linear function would pass both the vertical line test, making it a function, and the horizontal line test, making it a one-to-one function. This function is a parabola. So it is a function because it passes the vertical line test, but it is not a one-to-one function because it does not pass the horizontal line test. For it to be one-to-one, it has to pass both the vertical and the horizontal line test. So to give a quick example here, if we're given the information that f of 3 is equal to 6, so we plug 3 into f, we get an output of 6. The question is, what do we get if we plug 6 into the inverse of f? Well, remember, a function and an inverse, they undo each other. So for an input of 3, we get an output of 6. In its inverse, for an input of 6, that means we have to get an output of 3. So if we take 2, plug it into the inverse of the function, plug that back into the function, a shortcut, we just have to get a final output of 2. We're given f inverse of f of x. So we take x, plug it into a function, take the output, plug it into its inverse. A final answer, we would have to get x. Whatever you start with, the function and its inverse, they undo each other, you end up back where you started.